Okay, so we're going to look at powers and exponents here, getting used to some vocabulary and looking at how a power is created to find a value. So the directions say to complete the table by identifying the base, the exponent, and write each power as a product of the same factor. So that's a lot of vocabulary here. Here we have, these are called powers, then we'll identify the base, the exponent, and the factors. So for the first one, we have 5 to the 5th. Okay, now this is the power. When we look at the base, the base is this bigger number. That's kind of how you can remember it. So the base of this one is 5. And then when we look at the exponent, it's this little number up here to the 5th. And then when we look at factors, this tells me I'm going to take 5, the base, and multiply it 5 times. So 5, there's once, times 5, there's twice, times 5, 3 times, times 5, 4 times, times 5, 5 times. Okay, for the next one, -7 to the 4th. So the bigger number is the base, -7. And we're going to put -7 in parentheses. You'll find out a little bit why it matters if you put it in parentheses or not. My exponent is the little number to the 4th. Okay, so then when I write my factors, I'm going to do -7 4 times. So it's not -7 times 4. It would be -7 times -7 times -7 times -7. And you can see there's 1, 2, 3, and 4 of them. Next one, 25 to the 2nd. So the bigger number there is the base, 25. The little number, the 2, is the exponent. So this tells me I'm going to do 25 2 times. So I'd have 25 times 25. Okay, next one, 16 to the 1st power. So the bigger number is the base. 16 is the base. My exponent is 1. So this one would be easy. It's just 16 one time. Okay, and then the last one, 4/5 to the 3rd. So the bigger number is 4/5. And the exponent, the little number, is to the 3rd. So this tells me I'm going to do 4/5 3 times. So I'd have 4/5 times 4/5 times 4/5. Okay, so you can see that's 1, 2, 3 times. Now in all of these, we haven't figured out the value of them. We'll figure that out in a little bit. Also, when I say the bigger number, I don't mean the number that has the larger value. I mean the number that's written bigger. So notice these numbers are a big number, they're written bigger, and the exponent is written a little bit above, up to the right, small as a smaller number. So the bigger number is just because it's written bigger, not because it has a bigger value. Okay, so now we're going to do the reverse of what we just did. It says complete the table by expressing each product as a power and identifying the base and the exponent. So we're going to take the factor, the expanded form we call this, figure out the base, the exponent, and then write it as a power. So to find the base, we look at what number is being multiplied over and over and over again. So in this case, it's 1. So my base is 1. My exponent is how many times it was multiplied here. So I can see there's 1, 2, 3 times. So my exponent is 3. So then to write the power, I write 1 to the 3rd power. Remember, the base is the bigger number, that's written bigger, and the exponent is written to the top right. Okay, next one. I look at the number that's being multiplied over and over again, -42. So my base is -42, and we're going to put it in parentheses. Anytime you have a number that's negative that's multiplied over and over, put it in parentheses, and I'll explain more about this later. The exponent then is how many times. So I can see it's 2 times here. So I have a 2 for my exponent. So for my power, I have -42, put it in parentheses, to the 2nd power. Okay, for the next one with the 6's, I can see 6 is being multiplied over and over and over again, so that's my base. My exponent is how many times? So 1, 2, 3, 4, 5 times. So my exponent is 5. And then my power is 6 to the 5th. And last one, I have 1/9 being multiplied repeatedly. So 1/9. My exponent is 1, 2, 3, 4 times. So 1/9 to the 4th. And when I do 1/9, make sure you put it in parentheses because we want to show that this 4 belongs to the whole fraction, not just to the numerator. If I put the 4 without the parentheses here, it could be seen as 1 to the 1st divided by 9, so put 1/9 in parentheses. Okay, now we're going to start to find the value of our powers. So the directions say to write each product using an exponent and then find the value. This could also be known as like evaluating the expression here. So that's super important that you notice it says find the value. So first, number 1, I look at all the 3's here. Okay, so I notice that my base is 3. My exponent, I need to count how many times it was multiplied by. 1, 2, 3, 4, 5, 6 times. So that would be 3 to the 6th. And then I need to find the value. And so this is the part where you're going to need a calculator. I don't want you doing longhand multiplication here. So I'm going to do 3 6 times. So I have 3 times 3, there's twice, times 3 times 3 times 3 times 3. And the nice part about your calculators, the ones from the classroom, are that you can see on the display what it's telling you you have typed in. So I have 1, 2, 3, 4, 5, 6. Once I have the correct amount, I push equals, and I can see it equals 729. All right, 729. Number 2, I see I have 14 for my base, and it is twice, so 14 to the 2nd power. So if I go type it on my calculator, 14 times 14, there's twice, equals 196. Okay, number 3, I see I have 8, and it will be 1, 2, 3 times. So 8 to the 3rd power, to 8 times 8. Oops, I need to clear out what I had. That's important to notice. 8 times 8 times 8, there's 3 times, equals 512. Okay, number 4. 4 is a unique one. I see my base is 43, okay, and it was only multiplied 1 time. So 43 to the 1st power, I don't need to use a calculator for this because I'm not multiplying 43 by anything. The answer is just 43. That's the value of it. Number 5, now you need to notice I'm multiplying -2 for my base. It's very important you put this in parentheses. Otherwise, if you have no parentheses, it's telling you to take 2 and multiply it 3 times and throw the negative on the end, which we'll get to looking at more in a later lesson. So -2, and I have 1, 2, 3 times, -2 to the 3rd power. Okay, so on my calculators from the classroom, you're going to want to notice that the parenthesis buttons are right here, and then you've got the negative button here, and then 2. So when you type in -2, you'll do this first parentheses, negative, and then type 2, and then close the parentheses. On this calculator, it's going to look a little bit different. So -2 times -2 times -2 equals -8. So I'll write -8 for my answer. Okay, and last one here, number 6. I see I have 3/4 being multiplied, put parentheses around the fraction because I want to have that exponent to the whole fraction, not just the numerator. So I have 1, 2, 3, 4 times. So that's -3 to the 4th. Now, when I figure this one out, what I need to do first is I need to do 3 to the 4th and then 4 to the 4th. Because if we look back here, in the factor form, I have 4 times 4 times 4, 5 times 5 times 5. When we multiply fractions, we go straight across the top and straight across the bottom. So on the top, I'm going to do 3 times 3 times 3 times 3. So we'll try that here. 3 times 3 times 3 times 3. I've got 1, 2, 3, 4 of them. So the numerator is going to equal 81. And for my denominator, I'm going to do 4 times 4 times 4 times 4. Straight across the top, straight across the bottom. So clear this out. I've got 4 times 4 times 4 times 4. 1, 2, 3, 4 of them equals 256. Okay, next part, we're going to do the opposite of what we just did. So it says write each power as a product of the same factor, then find the value. So for number 7, 6 to the second. So I'm going to start with 6 times 6, that's twice. Okay, and I don't need to calculate for this. I know 6 times 6 equals 36. Number 8, I see I have 3 to the 5th. So 3 5 times. 3 times 3 times 3 times 3, 1, 2, 3, 4 times 3 is 5 of them. And we'll figure out what this equals here. 3 times 3 times 3 times 3, there's 4 times 3. Got 1, 2, 3, 4, 5 of them equals 243. Okay, number 9, 7 to the third. So I have 7 times 7 times 7, 3 times, equals 7 times 7 times 7 equals 343. Number 10, 18 to the first. So I'm taking 18 just once. So I don't need to multiply by anything. So the value of it will just be 18. Number 11, I have 0 4 times. So 0 times 0 times 0 times 0. 1, 2, 3, 4 of them. 0 times 0 times 0 times 0 equals just 0. And number 12, I have 11 twice. So 11 times 11 equals, 11 times 11 is 121. Okay, now we're really going to try to stretch our brains on this part, and we need to figure out the missing exponent. So the directions say write the missing exponent. So I need to think about this base of 12 and thinking about how many times do I have to multiply 12 by itself to get me the value of 144. So if I just start multiplying 12s, well, 12 times 12 I know is 144. So I already got the value of 144. So I can see I multiplied it 2 times. So that is my exponent there. Okay, number 14. 48, how many times for my exponent equals 48? This one's an easy one because I know if I just take 48, I already have the value. So that would be 48 to the first power because I only had it once. Number 15, 2 to the what power equals 8? So if I start multiplying 2's, I know 2 times 2 is 4. Okay, well that's not 8. I need to keep multiplying by 2 until I get to 8. So I multiply 4 times 2, and that gives me 8, which is the value that I had. So I can see I multiplied that 2, 1, 2, 3 times. So my exponent is 3. Number 16, negative 5 to what power gives me 25? So if I start multiplying negative 5's, well, negative 5 times negative 5, negative times the negative is positive 25. I can see I got the value there. So 1, 2 times, that is my exponent. 17, 1/3 to the what power is 1/81st. So the 1 to the what power, that doesn't really help me. But if I look, 3 to the what for my exponent gets me 81. So I'm going to start multiplying by 3's. Well, I know 3 times 3 is 9. That's not enough. I need to get to 81 for the value. So I multiply by 3 again. 9 times 3 is 27, which is still not enough. But then if I multiply by 3 again, 27 times 3 is 81. Okay, and I would expect that you're probably going to use a calculator when you get these bigger numbers. I'm just not typing it in the calculator here for you. So feel free to use a calculator. And then number 18. So the ones on the top, oh, let me go back. I need to put my exponent here. I had 81, so I got my value. So 81 to the 4th power. Okay, now number 18. 1 to what power gets me 1? That's not easy to figure out. But if I look at 15 to what power gets me 225. So I'm going to start multiplying by 15s. Well, 15 times 15. 15 times 15 gets me 225. So right there you can see I got the value that I needed and I multiplied it 2 times. So 15 to the 2nd power. Okay, and last part here. Now we're really going to stretch our thinking here. So it says, write the missing base. This is going to take a little bit of guess and check probably, unless you have really strong number sense with multiplying numbers repeated times. So I need to figure out what number multiplied by itself 3 times is going to get me to 216. So I'm just going to start with guess and check on my calculator. So I'm going to try 3 times 3 times 3, 3 times. Okay, well I can see that's 27. That's way too low. I'm trying to get to 216. So maybe I'll try 5. 5 times 5 times 5. Okay, that's 125, getting me closer, but too much. Not enough yet. I need 216. I'll try 7. 7 times 7 times 7. Okay, that's 343. Now this is too much. So I know if 5 was too low and 7 is too high, I'm going to try 6 times 6 times 6. Gets me 216. So I can say I know 6 to the 3rd is 6 times 6 times 6, which is 216. So the missing base here was 6. Now on number 20, I can use a little bit of number sense to figure out what number multiplied by itself twice is 400. Well, if I use this 4, I know that 2 times 2 is 4, so it obviously has to be more than 2, so I'm going to try 20 times 20. So 20 times 20 is indeed 400. So my missing base there is 400. Okay, number 21. Something to the 1st power has to equal 56. Well, this is an easy one because, oh, let me back up. 20 times 20. 56 to the 1st is just 56 here. Okay, number 2. Now, 10,000. I know that in order to get a 1 by a bunch of zeros, I have to multiply by powers of 10. So if I just start multiplying tens to get to this 10,000, I'm going to see how many times it takes me. So I'm going to start with 10 times 10. Well, I know that's 100. Then if I multiply that by 10 again, that's 1,000. If I multiply that by 10 again, that's 10,000, and that's what we're looking for. So I'm going to type them all in at once. 4 times I multiplied the tens by. So 10 times 10 times 10 times 10 equals 10,000. I can see 10 times 10 times 10 times 10. Okay, number 23. Something to the 5th power equals 1. Okay, well, if it equals 1, the only way to get 1 is to... So I would have 1 times 1 times 1 times 1 times 1, which equals 1. So 1 5 times is 1. Okay, and last but not least here, number 24. So I need to think what fraction multiplied by itself twice is 49. So it's a little bit easier to think about, okay, let's just deal with the 49 instead of 49 over 64. So we'll deal with the 49 first. So I'm going to look at the numerator and I'm going to think what numbers multiplied by themselves, okay, twice. So what number twice multiplies to be 49? Well, I know 7 times 7 is 49. So the top number in my fraction, my numerator, is going to be 7. Okay, then if I look at what number multiplied by itself twice equals 64? Because that's the denominator here. I know 8 times 8 is 64, so my fraction then is 7/8. Just look at them as two separate problems here that you have to figure out. So 7/8 to the second power equals 49/64. Okay, for the 10.1 activity, I'm going to explain and walk you through things here so you know how to do the activity. So you're going to have two dice that you're going to roll. You'll share the dice with your group. So step one, you're going to roll the dice. And then you're going to choose one number as your base and the other number as your exponent. So I'm going to do an example here. It says try to choose the combination that would get the highest value. So if you roll a 5 and a 2, you could have 5 to the second power, which would be 5 times 5 or 25, but you could also flip it around and do 2 to the fifth power. And when I multiply 2 5 times, it equals 32. So you'd rather choose 2 to the fifth because it gets you 32 points instead of 25. And then you'll find the value of your exponential expression and record the amount for your point value. So I'll do an example here. I'm going to roll 2 dice. I'm going to roll till I get a good number to use as an example here. You only get to roll once, so whatever you roll on the first time is what you get. So I have a 5 and a 3, so there's two options. I could do 5 to the third power, so that would be 5 to the third power, or 5 times 5 times 5, which I know is a 125. You can use your calculator. Or I could flip it around and I could do 3 to the fifth power. So 3 to the fifth. Expanded form would be 3 times 3 times 3 times 3 times 3. And let's see what that gives me here. So 3 times 3 times 3 times 3 times 3, there's 1, 2, 3, 4, 5 of them, equals 243. So I'm trying to get the highest points. So I wouldn't record both of these on my sheet. You would record just one of them. So I'm going to get rid of this one here because that's not enough points. Or that's less points than this one here. So you're going to keep doing that until you fill up your page, and then you'll find your grand total at the end. Remember, you only get to roll once. So whatever you roll, if you roll a 6 and a 2, that's what you have to keep, and then figure out if you want 2 to the 6th or 6 to the second.